Hey everyone, welcome to Tutorial Tuesday. When this is scheduled to upload, I will be at GDC, so that's super fun. So wish me luck there. I actually will be giving a talk, or will have given my talks at GDC, so that's pretty cool. I'm continuing my talk here on the 10 Commandments of Programming. So we've left off, we have these 1 through 5, and I've left all of my scratch notes over here and left everything here. So let's keep going. So let's jump in with number 6. This one maybe is a little more AI focused, but that's fine, which is develop tools. It's not really AI focused. Develop tools. A lot of new programmers come in and do everything in the debugger. Every configuration file is some XML file somewhere. The problem is that now you're the one who can make those changes. XML is not fun to edit. Even JSON, which is a little more human readable, is not fun to edit. No one wants to do that. If it's a small config file, who cares? But it's not going to be a small config file if you're making any kind of shippable thing. So make a tool. Make some kind of tool that you can use to edit this. Don't make it too early, but definitely make it. This goes double for debug tools, right? You need to have some debug tools. If you happen to have a way to get access to GDC talks, or maybe they'll make it free, who knows? One of my talks actually was about simple ways of developing tools. And I may do a trick or something here. I might do a tutorial on how to create some very, very basic tools and kind of go deeper than I was able to do in a 10-minute talk. So yeah, develop tools. They'll save your life. I mean, look how important just having an IDE is. Tools. Don't be above writing tools. Okay. Number 7, somewhat related. Use the right tool for the job. This one bugs me for a number of reasons. I see this in industry a lot. At several companies I've been at now, in gameplay, there's some kind of scripting language or higher level language often. Python was for The Sims 4, for example. I've used Lua in the past as well. And the problem is that people will get in their heads about, okay, every gameplay thing has to be in this language. Well, that's not always the right tool for that language. On The Sims, we had a posture graph, for instance. And that posture graph, you might have something like stand, and then, it would branch out to a bunch of different nodes. And these were all postures, where each of the, maybe these guys connect. Each of these nodes represents a different posture that I can be in, and each of these arcs here are transitions between those. So, sit at desk, stand at counter, and so on. So in order to know how to go from, sit at desk to stand at counter, we had to know that you had to do a stand at none and then here to do this posture transition. The way that we figured that out is with a relatively well-known algorithm called Dijkstra's algorithm. We did Dijkstra search across that graph. Now Dijkstra search is a non-trivial search. Don't quote me on this, but I think it's theta of v squared. For those of you who know about asymptotic complexity, I would actually have to look this up. I didn't look this up before the video. I think it's theta of a number of vertices squared. I'm going to put a question mark. I actually don't remember. Anyway, it's a non-trivial algorithm. It was all implemented in Python, and it caused us a lot of performance issues, where maybe that wasn't the right tool, right? That could have been something we would have gained significant performance increases just making it in C++. Unity, Unreal, there's all these engines. Unreal is not that great at making like a simple 2D mobile game. It just isn't. I would not use Unreal for that. I would use Unity for that. Unity is really not great at making a big, flashy, AAA-ish or even AA type game. It's just not good for that. Git, everybody loves Git, right? Git is everyone has a hard on for Git. They really do. And I don't get it. I'm going to write it in pink. right? I just don't get people's love of Git. I get why programmers love Git. Programmers love it because you can do trivial branching, and there's other fanciness that you can do, and it's sexy. Trivial branching is nice, and we don't care about the command line or the complexity. However, Git is garbage for game development, right? I mean, there's hacks around it and plugins around it, but core Git is absolute crap for anything binary, which is the vast majority of what I have to check in. Artists can't stand it because they can barely use it, right? It's super complicated. I have yet to find any halfway decent visual interface for Git. I guess there's a couple that are okay. I end up just defaulting to the command line. I've only used Git professionally once, and at that company, I just used the command line. It was just easier. Just dealt with the command line, set it up so that it could use my diffing tools and merge tools and stuff, but that was it. It was nice to be able to trivially branch, but man, any kind of binary asset, you're just hosed. Many professional companies that I've seen have a Git repository for their code and a Perforce repository for their assets, which is just ludicrous to me. Why would you split those? Anyway, that's a whole other rant probably. Use the right tool for the problem you're trying to solve, not the latest, coolest thing, right? Don't use utility theory if you need super exact values that are perfect, right? That sounds like a tree-like structure to me. That could even just be a straight-up decision tree or something along those lines, right? Use the right tool for the job. Use the thing that you need. If you need simple AI, use a state machine. If you need something complex and nuanced, use utility theory. You know, behavior trees are way over abused in the games industry, for example. Okay, number 8. This is mostly for people working in teams. Code reviews. Don't write code in a vacuum. Do code reviews. Here's the thing. Do your own code reviews. Every single time I check anything into my source control system, I look at every single file and I do a diff between what I had before and what code I entered to look at every change. Because, you know, for example, this file, this file is in progress. I would not check in all this commented out code. I just wouldn't check it in as part of a real thing or some of this other stuff, unless it was like a real temporary thing, right? I just wouldn't do that. I wouldn't check in these commented out variables because that's just messy. That's unprofessional. Sometimes I've caught actual bugs. Sometimes I've caught things where I'm like, oh, I am accidentally doing something ridiculous here. I accidentally left in a log that I didn't want to leave in, right? All those types of things. Make sure that you check that stuff. Review each other's code. It doesn't matter if they're senior or junior to you. You want to do these code reviews because another pair of eyes will catch things that you miss. When you're doing code reviews, it also helps if you're physically there so you can explain the code to them. If you can't explain the code to another engineer, you've probably screwed something up. Which brings me to my next point. And yeah, to do solo code reviews, absolutely. Look at your own code. Oh God, I'm just shuddering at how many bad check-ins I would have done if I didn't have that habit of literally doing a diff on every single file. Anyway, don't write clever code. Just don't do it. You know, don't write code that just like looks clever. That's some cool trick. You know, I did a rant on this at GDC during the AI Summit, where I talked about swap, and there's a couple different ways to write it. You can do this like fancy XOR trick, or you can do a temp variable, and people are like, oh no, the temp variable is super bad. Well, no, it's not, because it's optimized out by your optimizer. In fact, if you write simple code, your optimizer is much more likely to do its thing. If you write really crazy code, the optimizer might just be like, whatever, I can't optimize this. Don't do something clever. Don't, like, I once ran into code where someone had a string, like an STL string. They took a pointer to that string, cast it to some void star, and then later on, cast it back because they wanted some generic interface or didn't want to include string for some reason. I'm like, what are you doing? Because inevitably, someone somewhere down the line cast it to a C-style string, and that was causing the crash that I had to fix. So it's like, God, like, what are you even doing? So anything that's like clever, and I'm going to put clever in quotes here, like just don't do it. Just don't write, pseudo clever code. Write simple, easy code. Another example, someone in Rat Race, someone wrote the speech system, the speech database system, and the core speech database system was like this templated class that had 3 template parameters. There was only ever one instance of this class. It was essentially a singleton class. Why are there template parameters here? Refactoring is not hard. It can be a little annoying sometimes because you're rewriting chunks of code, but I would make easily refactorable code rather than writing, trying to get perfect the first time. It's not going to be perfect, right? There's a sort of school of thought that says, for example, optimization, premature optimization. It's not really that big of a deal to write performant code. It's much more important to write code that is easily optimizable, because you're not going to optimize everything. You're going to optimize the most important stuff, and it's the same thing here. Like, write simple code. It has actually probably a better chance of actually shipping. And if you have to refactor it, you can refactor it. It's not hard because you wrote simple code, so it's easy to refactor. 10, and this is my final one, and this is very specific to AI, sort of. A star, right, is not just for pathfinding. A lot of people I've talked to will say, oh, A star, that's the pathfinding algorithm, right? Well, no. I mean, actually, technically, where is it? Dijkstra is also a pathfinding algorithm if you really want to be pedantic about it, right? It's a single source shortest path problem. It's an algorithm for solving that. A star is an algorithm for solving a weighted graph where we can calculate some heuristic of generally how good choices are based on where I am now to the end goal. That's all it is. It's a single source shortest path across a graph, which means if you have any graph anywhere, you can solve single source shortest path for that graph using Dijkstra or A star, whatever. You just need to be able to calculate a heuristic. One of my favorite problems, I actually give this to my AI students, is you have this kind of grid, and I don't remember how big the grid is, but something like this, right? And this is like a sliding puzzle game. So, 2, 8, 1, 4, 3, and maybe that one's open, and so on. And these are all filled with the various things. I think it's actually 3 by 3. Doesn't really matter. My point being that in this little sliding puzzle game, 3 by 3, how do you make an AI that can solve for this puzzle? 9, 3, 6, 5. Actually, there's no 9, right? Because there's a blank space. So what am I? 1, 2, 3, 4, 5, 6, 7. That's what I'm missing. So something like this. So how do I turn this into the solved solution? Well, it turns out you can actually develop a heuristic for, how far away, like in this case, how many moves away is this piece Manhattan distance, a 1, 2, 3 from its goal. And you're just generally trying to make it go faster. So you can build a heuristic. And because you can build a heuristic, you can use A star to solve this. I was introduced to this particular problem in Artificial Intelligence, A Modern Approach, which is not a book not for the faint of heart. It is a hardcore computer science book, so be aware of that if you get it, but also a very good book. It's not about games, but it's about core AI techniques, and it teaches one thing that I've never seen in another, especially game AI book, which is a significant way of thinking about AI is as a search problem. You are representing some problem as some graph or some other such thing, and you are trying to employ searches across that. Utility theory, behavior trees, all that kind of stuff, right? Essentially, it's some kind of graph or tree expansion. I mean, a behavior tree is essentially a tree expansion. A decision tree is literally a tree expansion. Utility theory is, let's look at all these things and kind of, choose one of these things based on these sort of mathematical properties. So it's like we're searching across something. So all of those things are valid. There's a talk, God, when this would have been 2005 or six, maybe 2000 or maybe 2007, something like that. Jeff Orkin did his pretty famous talk on GOAP, goal-oriented action planning, and their core decision-making algorithm was A star, because it was basically a graph of possible like decision lines that could be made. I mean, that's what GOAP is. So yeah, those are my 10 commandments. I could probably make some of these less AI specific, but these are my 10 commandments. I hope you enjoyed the last couple of videos on this. Comment, like, all that fun stuff. Let me know if you have any questions or if you have any suggestions or anything like that for other things. Other than that, I will see you next time.